Energy balance occurs when the amount of energy we take in our food is equal to the energy we expend over time. So when the energy content of food balances the energy our body cells use, then our weight remains constant unless we have a gain or a loss of water. In many people, weight stability is going to persist despite having a large day-to-day variation in their activity level and their food intake. In the more affluent nations, such as the United States, a large fraction of the population is overweight because we have very easy access to delicious, high-calorie foods, and a lot of us have couch potato lifestyles. Both of those are going to promote weight gain in that our intake is much higher than our expenditure. Being overweight increases the risk of dying from a variety of cardiovascular and metabolic disorders, including hypertension, varicose veins, diabetes mellitus, arthritis, and also certain cancers. Since we're talking about energy balance, let's talk just a minute about what happens when we eat food. So when catabolic reactions occur, energy is released. A lot of that energy is going to be used just to perform the normal biological work, muscle contraction and transporting things throughout the body. Another bit of that energy is going to be converted to heat, which helps us to maintain our normal body temperature. Excess heat is lost to the environment. When the body catabolizes our food, the heat energy released can be measured in units called calories. So we consume our calories primarily in the food that we eat. And those calories come from the catabolism of carbohydrates, fats, and proteins. The catabolism of proteins gives about the same amount of energy as carbohydrates, with the catabolism of fat yielding much more energy. Pardon my break there. I wanted to make sure I was looking at the right information on this table I wanted to refer to. Looking at the calories in some common foods, the higher the calorie content of a particular food, the greater the amount of energy that's going to be released when it's catabolized or broken down. So, for instance, the energy content of a medium-sized apple is about 80 calories or 80 kilocalories. So we just simply say calories. The energy content of a slice of cake is about 247 calories. So suppose you eat the apple or the chocolate cake. Based on the calorie content of these food, your body is going to have to work harder, for instance, exercise, to release more energy to break down that chocolate cake as compared to the apple. So when we consume more calories than we catabolize or break down and release that energy in the form of heat, the result is storage of these molecules, and that can lead to obesity. In our bodies, the rate of metabolic reactions using energy is termed metabolic rate. So some of the energy is used to produce ATP, some of it's released as heat. So the higher the metabolic rate, the higher the production of heat. There are many factors that can affect our metabolic rate. So we measure it under standard conditions with the body in a quiet, resting, and fasting condition called the basal rate. And this measurement that's obtained under these conditions is known as your basal metabolic rate. There are several factors that can change or alter or help to regulate your basal metabolic rate. Thyroid hormones, remember T3 and T4, those are your main regulators of your basal metabolic rate. And as your blood levels of T3 and T4 rise, your basal metabolic rate rises as well. But this can take up to several days for the effect to be seen. Thyroid hormones increase your basal metabolic rate by stimulating cell respiration. So as cells are using more oxygen to make more ATP, more heat is given off, and again, body temperature rises. So this is called a calorogenic effect, burning the energy or releasing the heat energy from those calories. There are other hormones that also can have a smaller role on basal metabolic rate, and that includes testosterone, insulin, and growth hormone, but they usually only increase your metabolic rate by about 5 to 10 to 15%. Exercise, when you're doing strenuous exercise, your metabolic rate may increase up to 15 times the basal metabolic rate. If you're a well-trained athlete, these rates may increase up to 20 times the basal rate. During exercise, or if you're in a stressful situation, the sympathetic nervous system of the autonomic system is stimulated, and neurons are going to release epinephrine. That also is going to stimulate the medulla, remember the adrenal medulla, to release epi and norepi into the bloodstream. And of course, we know that one of the major effects of epi is to increase metabolic rate of body cells. The higher your temperature, the higher the metabolic rate. So for every 1 degree Celsius that we have a rise in our core temperature, that's going to increase the rate of our biochemical reactions by about 10%. So your metabolic rate can increase dramatically when you're running a fever. When we eat, our metabolic rate raises about 10 to 20% because of the energy cost of digesting and absorbing and storing nutrients. So this effect is called a food-induced thermogenesis, heat creation. And this effect is greatest after you eat a meal that's high in protein, but it's less dramatic after eating a high carb and high lipid diet. The metabolic rate of children in relation to the size of the child is about double that of an elderly person due to the high rate of reactions that are related to the growth of the child. And then there are other sort of miscellaneous factors, such as gender. Metabolic rate is typically lower in females unless they're pregnant or breastfeeding. Metabolic rate tends to be lower in tropical regions. During sleep, your metabolic rate decreases, and during times of malnutrition, metabolic rate also decreases.